Tuscany looks like one of the most peaceful places on Earth. Rolling hills, quiet villages, endless vineyards. Nothing about it suggests danger. But beneath that calm surface, scientists have uncovered something enormous. Using advanced seismic imaging, researchers have identified a vast reservoir of molten and partially molten rock hidden deep below the region, stretching for thousands of cubic kilometers. Its size rivals the magma systems beneath some of the most powerful volcanic regions on Earth. And yet, there are no active volcanoes here, no warning signs, no eruptions. So what exactly is hidden beneath Tuscany? Scientists studying central Italy have identified a vast underground zone of molten and partially molten rock buried between roughly 8 and 15 kilometers below the region. The discovery, led by researchers from the University of Geneva, points to a magma reservoir of staggering scale, estimated at around 5,000 to 6,000 cubic kilometers in volume. Numbers like that don't just sound big. They echo the scale of some of the most powerful volcanic systems on Earth. This volume is comparable to systems beneath places like Yellowstone National Park or Lake Taupo. The discovery was made using a technique called ambient noise tomography. This method uses the constant background vibrations that ripple through the Earth at all times. These tiny seismic waves, generated by ocean movement, wind, and distant geological activity, pass silently through the crust. As they travel, they change speed depending on what they move through. By placing sensors across Tuscany and analyzing how these waves behaved, researchers were able to effectively X-ray the Earth's crust. What they saw was unmistakable, a vast region where seismic waves slowed dramatically, indicating intense heat and the presence of melt. It was a massive, coherent system, and it had been there the entire time. Before we continue, don't forget to click on that subscribe button and like this video, as it's the best way to support this channel. Tuscany sits within one of the most geologically unusual regions in Europe, shaped by a complex interaction of tectonic forces beneath the Italian peninsula. Unlike southern Italy, where volcanoes like Mount Vesuvius and Mount Etna are driven by subduction, the Tuscan region lies within a zone of crustal extension linked to the evolution of the Tyrrhenian Sea. As the African plate slowly converges with the Eurasian plate, the subducting slab beneath Italy has retreated over time. This retreat has stretched and thinned the overlying crust behind the Apennine Mountains, creating what geologists call a back arc basin. In Tuscany, this stretching allows heat from deeper levels of the Earth to rise more easily toward the surface. The result is the formation of the Tuscan Magmatic Province, a broad area characterized by elevated heat flow, geothermal activity, and deep magmatic systems. Rather than producing large active volcanoes, this tectonic setting promotes the development of deep, long-lived magma reservoirs that remain trapped within the crust. This combination of crustal thinning, mantle upwelling, and slow magmatic input explains why Tuscany hosts intense geothermal activity without active volcanism. It is a region where the Earth's internal heat escapes gradually, shaping the landscape from below without dramatic eruptions at the surface. Tuscany was not always volcanically quiet. Millions of years ago, the region experienced significant volcanic activity. Lava flows, domes, and eruptions shaped parts of the landscape, leaving behind formations that still exist today. One of the most prominent remnants is Monte Amiata, an ancient volcanic structure that last erupted hundreds of thousands of years ago. But over time, that activity faded. The system didn't disappear, it retreated. Instead of erupting at the surface, magma began to stall deeper underground. Heat remained, movement continued, but the visible signs of volcanism diminished. What scientists have now discovered is the hidden continuation of that ancient system. Not dead, not active, but somewhere in between. What scientists found beneath Tuscany is best described as a magma mush. Instead of a giant molten chamber, the region is made up of hot rock saturated with small pockets of melt. Although the total volume of this zone is enormous, Only a small fraction of it is actually molten at any given time. Most estimates suggest that the melt percentage could be just a few percent of the total. That means the amount of magma capable of erupting is dramatically smaller than the headline number suggests. And more importantly, it means the system is stable. Because for a volcanic eruption to occur, magma must accumulate into a concentrated mobile body. It must build pressure. It must find pathways upward. In Tuscany, none of those conditions currently exist. What lies below is not a ready-to-erupt chamber. It is a deep, slowly evolving heat engine. Heat from this deep system rises slowly through the crust, driving the geothermal activity seen at the surface. Instead of feeding eruptions, the energy escapes gradually, venting through steam and hot water. The region is one of the most geothermally active areas in Europe. Steam vents rise from the ground. Hot fluids circulate through deep fractures. The famous geothermal fields around Larderello have been producing energy for over a century. But what makes the Tuscany system even more fascinating is that it is not confined to a single layer. Beneath the 8 to 15 kilometer reservoir lies an even deeper source of heat and magma, extending down into the lower crust and possibly the upper mantle. This deeper layer continuously feeds energy upward, maintaining the thermal structure above. It is a two-level system. At depth, hotter, more primitive magma rises slowly. Above, that heat sustains the partially molten zone detected by scientists. This interaction is what keeps the system alive, but it also helps explain why it remains stable. Because instead of rapidly injecting magma into shallow chambers, the system disperses energy over large volumes and long timescales. It spreads the heat, and in doing so, it prevents catastrophe. The term supervolcano has a very specific meaning. It refers to systems capable of producing eruptions exceeding 1,000 cubic kilometers of material. Events so large they can alter global climate. By that definition, Tuscany does not qualify. There is no evidence of past super eruptions in the region. There is no large, shallow magma chamber primed for eruption. And there are no current signs of pressure building towards such an event. Yet the comparison persists, because in terms of sheer size, the magma-bearing zone beneath Tuscany overlaps with the lower range of volumes seen in known supervolcanic systems. That's where the confusion begins. The reality is more subtle. Tuscany is not a supervolcano. It is a massive, deep, magmatic system that behaves very differently from the explosive giants people imagine. And yet, there is one detail that continues to capture scientific attention. Over very long timescales, tens of thousands to hundreds of thousands of years, systems like this can change. If melt were to increase, if it were to accumulate in a more concentrated form, if pathways toward the surface were to develop, then, in theory, the system could evolve into something more active. This is what researchers mean when they say it could contribute to the formation of a supervolcano in the distant future. Not soon, but geologically possible. It is a reminder that the Earth is not static. Even stable systems can transform, given enough time. The implications of this discovery go beyond volcanology. Deep magmatic systems are often associated with valuable mineral deposits. As magma cools and fluids circulate, elements like lithium and rare earth metals can become concentrated in specific areas of the crust. This raises the possibility that Tuscany may contain previously unknown underground resources. At the same time, understanding the structure of the magma system could improve geothermal energy extraction. By mapping where heat is most concentrated, scientists and engineers can better target drilling and increase efficiency. In this sense, the discovery is not just about what lies beneath, it is about what could be used. The most striking aspect of this entire story is how invisible it is. There is no towering volcano, no crater, no plume rising into the sky. Instead, the system operates in silence, kilometers below the surface, shaping the region in ways that are only now becoming visible through advanced technology. Perhaps the most important takeaway from this discovery is not about Tuscany at all. It is about how scientists understand magma systems. For decades, the dominant image of a volcano was a large chamber filled with liquid magma waiting to erupt. But discoveries like this are changing that picture. Most magma systems are not fully molten. They are long-lived, complex structures made up of partially molten rock, evolving slowly over time. Eruptions are not the default outcome. They are rare events that require very specific conditions. Tuscany is a perfect example of this new understanding.